Herzlich willkommen, der Leif und der Bastian von Cisco. Heute Distributed Data, Zentrale Policy. Und ja, würde ich direkt an euch übergeben. Viel Spaß.
All right, good morning, everybody. After SAP yesterday did their presentation in English, Leif decided to do ours in English as well. Leif is actually from Antigua, a very beautiful Caribbean island. He's very fluent in German, but he feels more eloquent in English.
And I don't like him.
Bitte?
So I said, and I don't like you, so.
Right. And yeah, I'm not so eloquent, neither in English nor in German. I'm not the really best presenter, but I'm just giving my very best. So if I switch back to German, I apologize in advance. Right, so my name is Bastian. As Leif, I'm working for Cisco. Cisco is a large IT company. We provide services. We also produce devices and products you use in the data center to run the data center, most notably networking gear. Networking systems are very complex systems. We have a lot of know-how there, but also security is a big part of what we're doing. We also produce x86 servers, Intel servers, so when we see larger companies with various workloads getting more complex, we think there is a better way to operate these servers, to get them into the data center. So we have the UCS line of servers that expose all settings they have via an API. So they're very well suited for virtualized workloads, very well suited for OpenStack, for example, where you can have a software telling the server what to be. And you can make the server whatever you want the server to be, whatever networking capabilities it should have, etc., for that application. So that's very well suited for these kind of cloud workloads. We also do produce software, a lot of software for data center operations, for example, making data centers more efficient, orchestrating in the data center, automizing. We have a lot of stuff going on in analytics right now. Actually, just a couple 100 meters away from here, there was a small startup we acquired a couple of months ago called Parstream. They were based in Cologne, and they built a database for IoT use cases. So it's sort of a big data, very fast big data appliance. You would, for example, use, I think the best example is wind turbines, where you produce energy. And there are hundreds of sensors in these wind turbines, and then you have to push the data. You have to do something with the data, but you cannot push it back to the data center. Even with the great Deutsche Telekom lines, it's sometimes not the best to push that back to the data center, so you try to analyze the data in the wind turbine. That's something we do with Parstream, based in Cologne. Then we have data virtualization. If you have various data sources, you want to connect to various data sources, there is a virtualization tool we provide, other things in the big data market. Also in software, we have a couple of open source endeavors, and we want to present 2 or 3 of those where we think this might be interesting to you, to the OpenStack community, or to people who work on clouds. That's one thing we want to present today. The other thing being, obviously, Cisco being a networking company, we yesterday heard from SAP there are lots of challenges in OpenStack and networking. All the companies basically tell us it's very complex. So we want to give a couple of examples where we can maybe automize the process and do things differently by tying everything together in a policy for the data center. Right. So that's the 2 things we're going to talk about. First, to set the stage, I think that's clear to most of us what we're talking about. What we're seeing is software is being developed differently. I think the iPhone came out in 2007. 2009, the app economy, the app stores really gained traction. I think in 2008, Amazon started, AWS. It's less than 10 years, and still it changed the whole industry, basically. And applications are developed differently. And everybody's talking how to move to microservices, etc. And that's what we're seeing as well. And maybe before we get into it, I'm curious, by show of hands, who is working for a company that also has developers in their company who's developing software. All right. And of those, who of those, I'm really interested, are working with modern tools towards cloud, microservices, etc., as opposed to traditional workloads? That's half. Okay, that's interesting. So not everybody, but maybe half of the audience sees in their company the migration towards microservices. All right. Also, how we access the applications changes, right? We don't work on terminals mostly, but nowadays we're talking about user interfaces that are natural. So I talk to Siri, and Siri understands. They have deep learning capabilities. Chatbots are a huge thing. I talk to bots, and they respond. So that's all drastically changing the environment we're working in. Right. So what we're seeing is the move from the traditional workloads, which will still be there in the future, towards cloud-enabled. And I think that has started with Amazon in 2007, 8, up until maybe a year ago or so, 2 years ago, the cloud-enabled, where we started private clouds with based on VMware, etc., in the enterprises to try to mimic this. And now I think what's happening, or what has been happening over the past 2 or 3 years, what we're seeing within Silicon Valley, but also in a couple of companies around here, is the true cloud native, right? So while the traditional workloads were based on VM, we started to mimic AWS in the private cloud with OpenStack. But that's basically what OpenStack is. It tries to mimic AWS in the private cloud. And we used something like Cloud Foundry, for example, to build development environments that are a little bit similar to what developers are used to in the clouds, right? PaaS, like Cloud Foundry, have certain huge advantages, but also certain disadvantages. Huge VMs, very complex relationships within the VMs, etc. So what's happening right now, or what has been happening over the past 2 or 3 years, is the huge container hype. So while PaaS is based on containers as well, mostly not Docker, but some other containers, what we see now is that people are trying to migrate away from the huge PaaS VMs on cloud native, right? And that's really just Docker with some orchestrating tools, etc. And we're right as a vendor trying to prepare for the next wave. That's been happening for 2 or 3 years now, and that's what we are facing when developing new stuff. So that's a stack, a potential stack we see, or that we see happening. You might have a scale-out infrastructure, and I'm not going to talk about this so much. I mean, I said we're producing servers for these things and networking gear for this. And then you have a very lightweight Linux kernel on top, maybe, and not a huge VM necessarily, right? And cluster managers, etc. And on top, you have some applications. So first you have services and applications on top. And that's a stack we think most applications will be developed against in the future, or are being developed right now. Actually, that's an example, predictive data platform. It's not exactly what we launched this week. This week we launched Tetration Analytics. That's an analytics tool Cisco launched to analyze what's happening in the data center. So we analyze the data center network. Everything's connected to the network, so we know who's talking to who, what's happening, and we save the information for 12 months. So you can go back in time, like a time machine, and know, okay, if I had an intruder, what did happen 6 months ago? Why does this outbreak occur? Or who's communicating to who? What's typical patterns in my data center, right? So that's a product, a big data analytics appliance you can buy from Cisco called Tetration. And that's using this kind of technology, not this exact stack, but stuff like Druid and Spark and things from the big data world. So while companies like your companies are building stacks like that, we are building these stacks as well and market these stacks and bring those into the data centers and enterprises. So, right, and one potential platform, not everything's going to be lightweight Linux on bare metal servers. It might run in VMs or whatever it is. One potential platform is OpenStack, right? For us, it's the most important platform. Cisco invested a lot in OpenStack. We're using huge clouds. I don't know if you know WebEx, for example, is a collaboration service Cisco is offering that's running on top of OpenStack, has been running for a long time. Our internal clouds mostly run on OpenStack, and we have lots of expertise, developers working in the community. But it is difficult, right? And I think that's why everybody's here. You want to learn how to do it. How are others doing it? How can you do it easily, etc. And that's why we have one offer in the portfolio, and I'm not going to deep dive into it. It's just a little commercial block for me called Matterport. We see companies mostly either you want to provide OpenStack as your core skill, and then you build your own OpenStack distribution, or you use your distribution and do it. What we have with Matterport is a managed OpenStack offering. So mostly companies just want to leverage, want to use OpenStack, but don't want to develop and want to live in the community. And if you just want to use the APIs and want to use OpenStack, that's a service on-premise. You use your hardware, or preferably our hardware, but maybe your hardware. And we install OpenStack on top, and you can just use it, right? As you would use Amazon. It's just on your premise in your data center. It's typical OpenStack distribution. It's hardened. It's HA, 99.99% availability. So enterprise-ready sort of OpenStack distribution for you. And then another offering I want to mention before passing the ball to Leif is the same Matterport I just mentioned together with Pivotal. If you're looking into a PaaS, classical like Cloud Foundry solution, there is an offering from Cisco to have Cisco Matterport as the OpenStack distribution managed. You don't have to build it, it's just there, and you leverage Pivotal on top. So if you go to pivotal.io/Cisco, that's something they are promoting and we're promoting to get you into the PaaS more easily and much quicker than you would if you would build everything yourself, right? Obviously, we do work with all the others as well, with OpenShift, with Apprender, but there's a very neat offering because it's just up and running very, very quickly if you're interested in Cloud Foundry, right? But again, we're not going to deep dive into these things, but we would like to show first a little bit about what we're doing to enhance, especially networking and the hardware-software integration in OpenStack. And then we're going to talk about some open source projects we're involved in that could be interesting if you're going towards cloud-native and container-based deployments in the future. Right, Leif.
Thank you. Good morning. All right, so we're talking about OpenStack and the different things around it. And OpenStack, like we mentioned, is not trivial. There are lots of different ways to do OpenStack. You can go, and there are different challenges around it. One of the things you think about is around support. If you're coming out of an environment where you say you've been used to VMware or Windows or even Linux, if you do Linux, you don't go and say, I'm going to run this in my enterprise, take some open source project, and then rely on this. You're going to go to a Red Hat or a SUSE or something like this so you can get support. The same thing if you are doing OpenStack. There are different ways of doing it. You can get standard distributions from Red Hat or from Mirantis and different things like that. But there's still going to be challenges, even for the people who are operating it. And if you go with these distributions, that's perfect. But one of the beautiful things about OpenStack is it is extensible, and you can add things to it and do different open source projects with it. But when you're talking about deployments, there's also going to be challenges around it, how you deploy it, what your installer is, and then you come down to other things around adding different projects to it. And it can become quite complicated. So there are different ways to say, all right, you need skilled people who can do it. And that's not, I mean, we have the Matterport offering. That's not what I'm trying to push here. I'm saying no matter what you go with, if you go with Mirantis or Red Hat or everything, you need to do it the right way. And one of the things that you want to talk about is, your issues. You're going to have problems at scale. And if you're running it in a development lab or in a test environment or something like that, and you have your pure software overlay network, and you're doing Neutron layer 3 in software, you're like, look, it works fine. Well, how many servers do you have? I've got 10, I've got 50, it works fine. All right, well, I mean, obviously we sell hardware, and we want to keep on selling hardware, and we want the hardware to give you value. But around the projects that we've developed around this is really where customers have come to us. And the point that I'm trying to make is you want to have the right tool for the job. If you can do lots of things in software, and everyone says software is so fast and hardware is really slow. And that's not true. Hardware is really fast. Software is really slow. Developing software is really fast. Developing hardware is really slow. But if I want something to work at scale, if I want it to be fast, it's got to run in an ASIC, and that ASIC needs to be intelligent, and we have to be able to offload to that. But we don't want to restrict ourselves to say, I need to be configuring this hardware the way I've done it forever. I want my software, I want to maintain the agility of my software. I want to be able to be fast, but I need to have certain things operating at scale in hardware. And a lot of the solutions, like I said, customers have come to us at a certain point where they get to a scale and it's like, oh, we're having problems now. The software is not going to be able to scale like this. We need to be able to offload it. We have to do other things that we just can't do today. And you could theoretically put a ton of investment and time into it and maybe get it to work in software. But is that really your core business? And is it worth you spending that time doing it? Because at the end of the day, that's not my business. I want to run an application on top of it, and I just want this thing to work. So that's why we have different tie-ins into our hardware, like into our server offering. We have plugins that can say I can do ironic, allow OpenStack to really tell my hardware, my server hardware, how it works. I have plugins around our Nexus offerings, around our router offerings, to really say I can use OpenStack commands, but that's going to configure hardware. And all kinds of different rich plugins that we have. And one example that we do, or first, just to go around some of the pros and cons of Neutron, is that Neutron has its advantages in terms of it's a very powerful API. You can, on the fly with your software, define your segments and your routers and all that stuff. But in terms of HA and failovers and how you're going to scale your layer 3, you're essentially going through your different Neutron nodes. And if you're talking about NATing and DHCP and all that stuff, at some point, when you really say you're getting into the hundreds of nodes or thousands of nodes, you're going to start breaking. And that's when customers have literally come to us and said, we need another option. And one example is our ASR plugin. ASR is a carrier-grade routing platform that we have. And this was actually, as far as I understood it from the BU, Blizzard came to us, so World of Warcraft. They run on OpenStack, and they came to us and say, we're in the thousands of nodes areas and we're having issues. We need to have actual routers doing our routing and our NATing and all that stuff. So what this allows you to do is to say, I can have my regular Neutron cluster and do my Neutron commands, but we have an ASR plugin so that essentially when you set up and say, I need a router, it doesn't do it on Neutron in software. The plugin will go to the ASR router and configure the router so that your routing happens on the router, your NATing happens on the router, and we do things like HSRP that we've been doing for years, so we have active failover if something breaks, so we can work seamlessly like that. And that's the point where you say, you get to a scale and you don't have to worry about it, you just put in this plugin and you make it work. So we can take this a step further and start talking about how does a normal network work? Well, and why are there issues in terms of automating traditional networks? If you look at a normal network, it's traditionally has been configured with CLIs. There's also ways of saying, well, now I have an API for this network and I can script it and do all this stuff. It's like, yeah, you can script it. But actually, in reality, you have to script it. It's not a privilege, it's a burden almost. So you're just like, look, we have all these hooks and APIs and all that. Yeah, but you still have to do it. And that's not my job. I don't want to do that. I'm going to have to, all right. So traditionally, a step-by-step thing. I configure one box and get that to talk to another box and configure the next box to get to another box. They're all done with CLIs. And no matter how sexy I say my interfaces and my scripting are, I'm still making one box talk to another box. And going onto that box, configuring a protocol, configuring an interface, making sure the IP is on it, and all that stuff. And is that really the way we want to do it? And Cisco has come out with basically our answer to doing software-defined networking in a data center. It's called ACI, Application-Centric Infrastructure. And one of the fundamental differences between ACI and a traditional network is it's complete policy intent-based. I have a network fabric that brings itself up. I plug everything together, and I connect my controller to a couple of those switches. The switches bring themselves up, find the controller, and they're ready to go. I don't have to configure anything for power on auto provisioning. That works out of the box. So I literally stick the stuff together, it comes up, and it works. So other people say, well, I can script that, and I can do my power on auto provisioning server and all that stuff, and make it work basically the same. Okay. But the power really comes when I start configuring my policies. Because we've created an operating system that runs on the switches that don't basically respond to a script saying do this and do this and do this. It's really a declarative model, so an intent-based model where I can say, I just tell my controller, this is what I want. I create a policy on my controller, and my infrastructure understands how to enforce that policy. So that's an important point to understand. The controller, after I create that policy, the controller doesn't go down to every switch and say, you do this, and you do this, and you do this, and configure this interface like this. The controller is not in the control plane. The controller does not execute a script on every box. The controller, I create a policy and say, this is how forwarding works. Even if it says, on this switch, I have a virtual port channel. I simply have a policy that says, if your name is 102 and 101 and 102, on these ports you have a port channel with these things. And now the other way, what happens is the switches look at the policy and say, oh, I'm 102, and I configure it myself. The controller has not done this. And that's a very powerful thing to start working with policy, because, and also what that allows you to do is give you a full visibility, just basically with the way the fabric works, is in order to have that forwarding, we have a VXLAN overlay and all that stuff, but the beauty behind that is that that stuff just works out of the box. I don't configure a VXLAN overlay. I don't configure how the boxes connect to each other. That just happens by itself. And because I'm working over a controller and the entire fabric runs off that controller, my policy is the same whether or not I have 2 switches or 20 switches or 100 switches. It's one fabric operated by one policy over one controller. So then we're here at OpenStack, the German OpenStack days, and you ask yourself, well, why do I really care about this? If you're here, yesterday in the SAP session for scaling Neutron, Martin Klein asked the question, like, how many people here are networkers? How many people here are networkers or have a networking background? See, not a lot. So that's why my point is, why do you really care about this? Because you don't do networking. It's not your job to do networking. It's like when you start something that's a bit more complicated and you don't really know how it works, you just say, well, what do you want for it? I just want it to work. I just want it to do the thing, and I don't want to understand it. I just want it to work. And that's what we're trying to do with ACI. It is a network that just works, and your integration in terms of if you aren't with a networking background and you want it to work, the amount of effort that you put into it is minimal. Because you simply tell a controller, say, this is what I want. You don't have to worry about now, well, I need to make routing work, I need to make VXLAN work, I need to make this work, no, you just tell the controller, this is what I want. And on a very simple level, like a traditional Neutron model works much like a regular network. I create a segment, I create a router, and I make that with IP addresses and all that stuff and make them talk to each other. But at the end of the day, if I'm offering services, I have one service and I want it to talk to another service. And then there's this annoying guy in security and compliance that says I need to make sure I restrict the ports and have a certain policy and how I do that. There was a guy yesterday in the Volkswagen session. He, rightly down front, he's like, well, you have this platform and you let your developers run wild on it. how do you ensure that what they're doing is compliant? How do you ensure that what they're doing is not violating security policy? How do you know that your boss is not going to get fired because you let this guy do whatever he wants, and now he's violating something, some security policy, either leaking information that's company secrets, or even worse, something that is legally required to be kept secret, and now your boss is not just going to get fired, he's going to go to jail too. So how do you do this? Like, the guy says, I want Service A to talk to Service B. That's what I care about. And the compliance says, like, well, I have to have this policy in place. So you can now create this model within ACI that simply says, I want this group of servers to talk to this group of servers, or I want this container to talk to this container, or this VM to talk to this VM, or this bare metal, and they're all the same, grouped together, and can be forwarded based on the same rules. And we've ported this now to OpenStack, and a thing that we call group-based policy. And group-based policy is also completely open. There are other companies who are also configuring or writing things for group-based policy, which essentially says, I want this group of servers to talk to this group of servers, or this group of containers to talk to this group of containers. I can define them based on a VLAN tag, on if they're in vCenter or if they're in OpenStack or whatever. And then I have a contract between the two groups that says this is how they're allowed to talk to each other. And this can be pushed out of my orchestration tool via a single REST API call. So I don't have to worry about how the network actually works. I just do my REST call and say, this is how I want traffic to be forwarded. And that's why you care, because it's going to make your life easier. It's going to make you do less work, or be able to focus on the actual work that you get paid to do. So again, why ACI is good for OpenStack is it simplifies things. You have less work to do. It's a distributed, scalable virtual, or you have overlay, you have underlay in one single fabric. It's controlled via a single controller that has a complete open API. And when I say completely open, there's nothing that you cannot do via the API, but the other way around, you can only use the API. We offer a GUI with it, based on HTML5. All that is, it's an HTML5 application that creates the REST calls to our API. So if you can configure it yourself via your own scripts, straight into the API. And there's nothing you can't do via the API. We do things like hardware acceleration. So everything that we do in VXLAN or VLAN or whatever is line speed 40 gig non-blocking. If you're going from container to VM to bare metal, it's line speed non-blocking. There are no gateways, there are no bottlenecks. If you go from underlay to overlay, it's one fabric, one policy that gets enforced. The same thing with operations and telemetry. You have full visibility of the entire fabric at one time. So you know where everything is, behind what switch port, behind what server is what MAC address, what IP address, who can talk to who. And now with our announcement from last week with titration, your power is on steroids now. So our hardware is able to give you full net flow export plus more information, and that gets put into a big data cluster and stored for a year. And we also have agents that go on to every end host and will give you the full information. So I know exactly who is talking to who at what second. And we're able to search in real time everything that is going on in your data center at 40 gig, 100 gig line speed. Talking about 8 billion searches in a second, or 8 billion flows to search in a second. And that's stored for a year. So that means that if you get hacked, we can tell you really quickly if you're getting hacked, because we know how normal patterns work in your network. We know exactly who's been talking to, and all of a sudden someone else is talking to someone else. We can tell you right away, look, there's something weird going on. Take a look at it. And if something weird happened 3 months ago, you can search in real time what happened 3 months ago. It's extremely, extremely powerful. It's basically an insurance policy telling you, normally you get buy an insurance policy so that after something happens, you get covered. This is basically an insurance policy saying, you pay your policy and nothing will happen, because we can tell you as soon as it's going to happen and shut that down. I mean, look at LinkedIn. How did they find out that they got hacked? The information got published on the internet, and they got hacked years ago. So how do you do this in containers? And why are we talking about containers? I was surprised in Austin, like the biggest track that I saw at the OpenStack Summit in Austin was about containers. And you ask yourself, why? Well, we're going in the direction of cloud. And things started before you had your pets, and now you're going into your cloud applications. And you talked about OpenStack with, because maybe in the beginning they didn't have all the HA and all that stuff around it, that they said, well, write your application so that if something breaks, it doesn't matter. You don't need HA, so you don't build it into that. And it makes sense. But now you're really going in the direction of microservices and all that. It's like, do we really still need to do all this stuff in VMs, or can we do it in runtime and just make it in containers? If we're going to split everything up into microservices and we're going to have the things work, have the applications work so that they don't break, or if something breaks, it doesn't matter, why should we make the stop with VMs and abstract the hardware? Let's do it in containers. Okay, sounds good, but it's not really easy to do it, because if you start working with containers, it's a bit different than VMs. I've abstracted my hardware into VMs, and I can still control my interfaces, and I can still control how the network works and who does what, and I can still be compliant. With containers, it's a completely different ballgame. You have all types of different containers. They're doing all types of different things. They're talking to different. It's a lot harder to control it. And again, it comes down to the whole compliance thing. VMs I can control. It's basically a regular machine. And I was able to do it in bare metal. Now it's just virtualized, but I can still control my compliance and all that stuff the same way. Containers, it's a whole new ballgame. And that's why it's a bit more difficult to get there. And there's no way to control who has the priority, who stops where, who can do what. And that's where we start coming in with a different project called Contiv. So if we're working with containers and you have all these different ways of deploying and orchestrating them, you have your mesosphere and your mesos and your Dockers and your Kubernetes, and you want to be able to use those to deploy your environments. But at the same time, they need to be running on an infrastructure. You're going to say, well, I'll just get commodity, whatever. It's like, yeah, you can, but then you work with the least common denominator. And what if you switch between different worlds? If you do still have things that are mode 1, if you do still have things are running in VMs and I need to combine them, how do I control that? And how do I leverage the power that this infrastructure can give me? And that's what we want to do with Contiv. It's a completely open source project. It's free. It's just allows us to hook into our infrastructure. It's open source, so it means that it is completely agnostic of the infrastructure that's underneath it. You can use the policies to control your environment, but obviously because we're paying the people to develop it, we're going to say, well, make sure you can do it with anything, so you have free choice to do whatever you want, but if you use a Cisco infrastructure, you're going to have advantages with it. You're not going to have a disadvantage if you don't, but it'll just work a lot sexier if you do it with a Cisco infrastructure. So you have focus from the container industry trying to just get your applications to work, and then you're going to move from development into production, and things are going to be a bit different. So you get your one of the beautiful things about containers is that you just develop it on your laptop, and you can create your environment, get everything working, and now you throw it over the fence and now make it scale and go into production. And they're like, really? Just like that? Yeah, just like that. Well, getting down to the guy from the Volkswagen thing who asked the question out of operations, like, well, how do I make sure that this is compliant, he's not violating security and all this? And that's what Contiv is going to do. It gives you an ecosystem within your container environment to create policy for networking, for storage, and for compute. So I can say, and it is quite literally, how it fits in is you have different layers of Contiv plugins that will go into your orchestration tools, that will go into your scheduler, and then into your runtime engines that allow you to create these different groups. So I say I have a Contiv database group, I have a Contiv application group, and then when I generate my containers, I give them interfaces into those different groups. And I have rules set up on how these different groups can talk to each other. So if I deploy a container into my database group, he can only talk to other things based on the rules set up from these groups. And if I have my Contiv put into my schedulers, that means I can also create rules around where are these containers allowed to be deployed. So if I have my beautiful environment where things get put up and down within seconds, I can also say, well, based on these rules and these things, I can deploy them here, I can deploy them there, and traffic can be forwarding based on these sets of rules that I set up. And I don't have the burden as a developer to say, I need to pay attention to this. But because up to now, there is no real solid solution on how to control it. And this gives you a framework to be able to do this based on policies. And again, back to the power that policies give you, like in ACI, like in Contiv, is I can establish these policies centrally at one time. My infrastructure, my data plane gets completely distributed, and I have an infrastructure that is capable of enforcing these policies. And I don't have to make sure that every step along the way, I make sure you're here and you're doing it like this, you're connected to that switch that does it like this. I have a single environment that I simply say, deploy into this interface, and I don't have to worry about it. And we also do things that we want to tightly integrate into the container environment, but focus on things that happen, again, at scale. And scale is a big deal around containers, because if I deal with a VM world, you're talking about 10, 20, 50 VMs on a single node, or maybe more if you're a bit daring. But when you go into containers, you're talking about hundreds of containers on individual things, and talking about speeds, things coming up within seconds and going back down within seconds. And if I want to be able to provision a network at this speed as well and have things work, and not just a network say, here I am, I'm IP, I'm doing everything, I'm allowed to do everything, but if I want to be able to control it in terms of access lists and firewall rules and all that things, I need something in place to do this, and that's something that a policy infrastructure will allow you to do. And because the policy infrastructure that we've created for Contiv is similar to the policy concept in ACI, if you do choose to have an ACI network, that means that if you're virtual, like a VM-based, container-based, or a bare metal-based system, you have a single infrastructure. So I have Contiv working my policy between my containers, but my infrastructure understands the same policy and can enforce it the same way. So again, there's no gateway, no bottleneck. It's a single network with a single policy that understands itself. And we also then work at scale, because not only did we create the Contiv as an open source project, we have another open source project called FD.io. And FD.io essentially has open sourced our packet forwarding engine. So Cisco has, over years and years, developed a very, very powerful packet forwarding engine. And we've open sourced that to allow you, and allow in terms of in Contiv, to not use the Linux TCP stack, but use the Cisco packet forwarding engine, which will give you a much, much higher performance in a virtualized environment, a containerized environment, or anything going in and out of a Linux box. We're going to give you multiple 10 gig performance out of Linux machines. That's in a normal environment with this density of containers and all those things. A regular TCP/IP stack from Linux will just choke. So how do you put this all together? And it's not just talking about, I've only scratched at the surface of it in terms of how Cisco's infrastructure with ACI and with Contiv starts, and with the ASR plugin starts talking about how we can offload different things into hardware and create policies around how the network works in OpenStack and with containers. But there's a lot more things in a container stack that we have to keep track of. And everyone talks about pets versus cattle. And so our VMware VMs were our pets, and now you go to OpenStack and that's cattle. And because you just don't have to care, as long as the whole herd is alive, it's still good. But you have to think about that a bit more, because a pet, anyone could have a pet and keep it in their house and give it some water and stroke it, and if he gets sick, you take him to the vet and you make sure that he's doing okay. But are you going to take a cow into your house? They have pretty eyes and everything, but if you bring them in your house, you're gonna have issues, and much less a whole herd. So the point here is saying, if you're going to be dealing with cattle, you need different tools, you need different infrastructure, and you have to handle them in a completely different way. And so that's not trivial to say that it's now they're just cattle, we don't have to care about, write the application. There's lots of things that go around it. There's a whole set of things. So we go from, if we're going from n-tiered application now to microservices, n-tiered before with all our pets and your web and your app and your database stuff works, but now we're going to break this apart into microservices. And if you want these microservices to work, they have to have different resources. Just like cattle, they need a big feedlot. They need all kinds of different things. And at scale, you have your pet and everything, and you take them for a walk, and they do their thing, and you pick it up and you throw it away. But if you start dealing with cattle, and they start scaling, you're going to really be like, oh, I did not realize there's literally this much shit to deal with. So you start tearing things up into microservices, and there are advantages to it, and that's why companies like Airbnb and Facebook and Uber, and they get it. They run on these microservices, and that's what they do. And they scale really fast, and it's really powerful. And I'm sure a lot of people are thinking, yeah, well, I'm not Facebook and Airbnb. What am I going to do with this? There are definitely advantages to this, and people want to develop like that. They want to start working in a microservices cloud-native environment because they're able to write their software more flexibly, more agile, and just focus on different parts. But there's a lot of other stuff that are in there. And Facebook and Airbnb, they can hire hundreds of people to create all this magic and make everything stick together and get all these different services working. But a startup or any other one trying to get into this says, I have to hire 100 people to do this. I don't even have 100 people right now. Is it really worth it? And that's where Cisco wants to come in with a couple other open source projects to kind of help out the enterprise where say, I want to move into this part, but there's so much work in order to get that environment running stable that I don't know how to get into it, or it's going to be really difficult to ramp up to that stage. So I'm going to let Bastian take you home in order to say what we're doing in that area.
Right, so I'm not on, am I?
Yep.
Yeah? All right. So first of all, what happened a couple of years ago was that, 3 years ago, that when developers tried to be more agile, we had the huge wave of PaaS software, Cloud Foundry and OpenShift and Apprentice, etc. And we still see this a very valid option, and you develop in your PaaS environment. And what Volkswagen yesterday said and others said, it's not enough that you provide just an OpenStack virtual machine, but you need to provide something else in addition to that for the developers to stick and to be interested in the solution. Just an OpenStack VM is not enough. And that's why at Austin, or I was in Tokyo at the OpenStack Summit, containers was the one huge thing, and everybody was discussing, do we need OpenStack if we have containers, etc. And I think the answer is you need both, and you need to integrate it. Anyways, the general point being, what's happening with PaaS is that you have a huge virtual machine, there's a lot of stuff going on, but you still have silos outside, you need to connect to data sources, etc. In these huge VMs, there are lots of services happening, microservices, containers, usually not Docker, but other containers, and they're talking via HTTP and other protocols, not typical networking, and it's really difficult to manage because it's so huge. And that's why what's happening at the moment, or what has been happening, is that even the traditional PaaS systems like Cloud Foundry integrated what's happening and being innovated in the container space. And so Cloud Foundry supports Docker now, and I think OpenShift is completely based on, or always has been based on, Kubernetes and so on. So we see this happening, but we also see a huge new wave to container-only stacks, right? So as opposed to having a huge PaaS VM, have a very lightweight container stack I mentioned in the beginning already. And if you do that, if you want to have a container stack and offer that to your developers, you have maybe your OpenStack platform, and then you need an OS to run on there. And you don't have a huge OS, you usually have a very lightweight OS, like CoreOS or Atomic or some other things happening. Then you need a container engine, obviously, Rocket or Docker being the most prominent. But only the container engine is not enough. You need an orchestrator. You need to orchestrate all the containers because now we talk about pets and cattle. Now everybody's talking about ants or the containers running around. So you need to orchestrate that. So you have Mesos, you have Kubernetes. I think Docker is coming out with Docker Swarm. So you need to integrate that somehow into the stack. And we see actually all. It's not that one is, I think Kubernetes is more used in app development. Mesos seems to be more used in data development. So we see the data developer as the new person who's doing a lot of cloud stuff. You have repositories, you need storage, persistent storage, you need networking. We talked about Contif as one example. In addition, you need some, some logging, metering, you need some tools to have this enterprise ready, of course. And you start setting up Kubernetes, and I bet in every company there's someone who experimented with doing some sort of orchestration of containers. And he realizes, okay, I need logging, I need metering, I need security, I need some enhancements here and there. And he's not developing the application, he's just building the stack, and that takes half a year usually to do that. That's one thing we want to propose. That's Mantle.io. That's another open source project. Mantle runs on bare metal, runs on OpenStack, mostly OpenStack, and also on public clouds, Azure, Amazon, you name it. And Mantle is basically nothing more than the tools you need for deploying a container stack. So all the stuff we saw before, the open source tools, but integrate them in a suite. So you don't have to build that suite yourself, but you can use it. You can exchange server. So there's Mesos, and there is also Kubernetes. Maybe you want to have Mesos, maybe you want to have Kubernetes. You can both use both. Docker Swarm will be integrated. It's an open source project. Anything can be integrated. And you provision via Terraform to some other workloads, VMs, etc. So that's just, we want to raise awareness for this. I think it's really neat, especially less for the infrastructure guys. I think it's more interesting for the developer guys who work with Kubernetes in these things and try to get it running. And it takes very, very long to get it running, to abbreviate that process. So Mantle.io is worth looking at. And now, how does it all tie together, everything we talked about? I think you need a platform at scale. So usually you don't see it in the lab. You see it not maybe in the pilot, but at some point, like SAP said yesterday, at some point, the infrastructure is going to be the limit. If you have a cloud and you do it properly, the problem will be what did SAP say? I think to bring the hardware into the data center is the biggest problem, right? So once it grows, it's growing rapidly, and you need to configure it very, very rapidly and bring it into the data center. So you need an infrastructure that can be capable of doing this. And then you have your OpenStack on top. Then, because the developer wants to see more than a VM, you probably have, in the future, you will have some sort of container stack. And then on top of that sits a continuous integration, continuous deployment suite. We're not going to talk about that. Cisco is thinking about doing something like that, continuous integration, continuous deployment for the container space. Sort of a cloud-native DevOps platform. We're thinking about launching that. Anyways, what we want to talk about, or what we want to raise awareness here for, is the OpenStack integration into the hardware, the OpenStack integration into the containers, containers talking to the hardware, talking to public clouds on the private cloud, and then somehow tying it into the what the developers are doing in their development environment, continuous integration platform, right? And that's where Contif then comes into the game, what Leif talked about. That's basically the policy engine that goes from the developer environment down to the hardware so that you can deploy using predefined policies and not have to touch individual systems, right? Okay. Quick mentioning of two Linux Foundation initiatives we're working, or we were founding members of, the Open Container Initiative and Cloud Native Computing Foundation. I think that's two foundations to maybe check out if you're interested in the container space. OpenStack Foundation is something we are very involved in as well, obviously. That's probably well known. All right. To close it off, I have only two more little announcements. One is this one. That's a picture of a voucher we hand out at our stand. We have a stand together with Deutsche Telekom. As you know, Deutsche Telekom has various clouds. I think everybody's aware of the presentation yesterday where Huawei presented the stack, the Open Cloud Initiative, I think. OpenStack-based telecom cloud competing with Amazon. then the Deutsche Telekom has an Azure, Microsoft Azure offering in Germany. And also what we're doing, or what we've done, is building an intercloud with Deutsche Telekom. That's an OpenStack-based platform for, let's say, more enterprise-ready workloads. There will be SaaS offerings on top of the Deutsche Telekom intercloud. We will have hybrid cloud scenarios, etc. And that's built on Cisco platform at Deutsche Telekom, also in Magdeburg in the cloud data center in Biere. And if you want to try out the intercloud like internet, right? Trying to connect various clouds, your private cloud and the public cloud. If you want to try out, I think there is a €250 voucher we give out in our stand, or Deutsche Telekom is giving out at the Cisco stand. So that's one thing I want to mention. And the other thing, obviously, we are giving away a quadricopter in the thing this afternoon. I think you have to, there are flyers at our stand. I'm not sure what you have to do. Maybe leave your visiting card or something, and you have the chance to win a quadricopter this afternoon. So with that, I want to thank you very much for your attention. I hope there were a couple of open source projects, some stuff about tying hardware, integrating hardware into your cloud, OpenStack and container-based cloud. And if you have any questions, we're still here the whole day and happy to answer. Thank you very much.